Hey y'all. The past couple of days we've been studying quadratics. We know about the quadratic vocabulary. We know how to find max and min. We know how to find the zeros. And we recently took a look at how to solve a quadratic equation by doing the square root method and by graphing it. Today we're going to take a pause from solving the quadratic equations and we're going to recap factoring. And then in the next lesson, we'll learn how to use factoring to solve a quadratic equation. So there's going to be all kind of different ways to solve a quadratic equation. So far, we know how to do the square root method and we know how to solve it by graphing. Today, we're going to pause just for a moment and we're going to recap how to do factor, greatest common factors, binomials, things like that. And then we'll use that skill to help us solve a quadratic equation. You definitely want to make sure that you write this down, get a little sheet of paper. I'm actually going to be making a foldable, and then you want to make sure you keep this out in your notebook as we go over factoring, because factoring will pop up here and there as the semester goes on. So today's lesson, we're going to be doing factoring progression. Your first step when you factor is to find the greatest common factor. So this is very important. So make sure as you are making your foldable that you highlight this, star it, write it down twice, whatever you need to do. Your very first step when you factor is to find the greatest common factor. On the inside, we're going to take a look at 8 problems. We're going to start from way back when, basic factoring, and then we're going to work our way up to maybe a little harder ones, but not too bad. But we're going to start from the basics and then progress as we go. So the first ones that I have, I'm just going to make sure you know how to find the greatest common factor. So GCF stands for greatest common factor. I want to make sure you can find the biggest number or variables that 2 or 3 or 4 terms share. So we're going to start by doing a factor tree. When you do a factor tree, you're going to break your tree all the way down into prime numbers. So this first one that I have here, it says find the greatest common factor of 30 and 50. I already did a factor tree for 30, and I already did a factor tree for 50. You want to break it all the way down to prime numbers. Prime numbers, their only factors are the number 1 and whatever that number is. For example, 5 is 1 times 5. 2 is 1 times 2. 3 is 1 times 3. Those are examples of prime numbers. 6 is not prime because I can break that down. 10 was not prime because I could break that down. So those are what we call composite numbers. So when you're doing a prime tree, break it all the way down till you only have prime numbers. Now, I chose to do 30 as 5 and 6. You might would have chose 3 and 10. Or you might would have done 2 and 15. It doesn't matter where you start your factor tree off. It's going to break down to the same thing. Same thing with 50. Maybe you wanted to do 25 and 2. So it really didn't matter as long as you started with 2 numbers that multiply to give you the number up there. So anyway, I already went ahead and did my factor tree for each one. I'm going to circle what they share. So looking here, I see they share 5, and I see they share 2. So they each have 1, 2, and 1, 5. So their greatest common factor is 2 times 5, which is 10. So the greatest common factor of 30 and 50 is 10. Now, I'm pretty sure you probably can just look at that 30 and 50 and be like, oh, Ms. Carver, yeah, the biggest number they share is 10. But it doesn't help. It doesn't hurt for you to do a factor tree if you're not there yet, particularly when we get to longer problems and variables and things like that. But regardless, my greatest common factor of 30 and 50 is 10. Next, we're going to find the greatest common factor of 12a squared b squared c and 18ab to the third. Again, I already say that stuff a little bit of time. I already did my factor trees. I already broke it down to prime numbers. This told me I had 2 a's, so I wrote AA. 2 b's, I wrote 2 b's, and I brought the c down. Same with the a and the 3 b's. We're going to go through and circle any numbers or variables that they share. I see a 2 and a 3. I see a 2 and a 3. Variables, got an A, and 2 B's. So their greatest common factor is a 2, a 3, a, and 2 B's. So if I multiply all that out, they each have 1, 2 that they share, 1, 3 that they share, 1 A that they share, and they each have 2 B's. So you multiply all that out, Greatest common factor, 6ab squared. Number 3, find the greatest common factor of 6ay to the third and 18yz. Again, I already did the factor tree. Break it all the way down to prime numbers and make sure you list out the variables. The exponent tells you how many variables we have. So this is y to the third. I got 3 y's. I have 1 y, 1 z. I wrote that down. We're going to go through and circle any numbers or variables that they share. I see a 3, and I also see a 2. They don't share any x's, but they do share a y. So their greatest common factor is a 2, a 3, and a y. They each have 1, 2, 1, 3, and 1 y that they share. So I'll multiply that out, and that gives me 6y. So that is a recap on finding the greatest common factor. You do your factor trees, break it all the way down to prime numbers, list out your variables, and circle what they share. Now we're going to use that to help us factor. So factoring is working backwards. So we know how to do the box method and distributive property. Now we're working backwards to figure out what would we get in parentheses. So we're kind of working backwards to get what I normally would give you as the problem. So we're going to factor 14c squared plus 2c. So I already did a factor tree for 14c squared, and I already did a factor tree for 2c. When you're doing these, your greatest common factor goes on the outside, and then everything else goes on the inside. So I see that they share the number 2, and I see that they share the letter c, the variable c. So that is their greatest common factor. So 2c is going to go on the outside, and that 2c is the greatest common factor. So your greatest common factor goes on the outside. Leftover factors go on the inside. Left over here is a 7 and a c. I'm going to multiply that. That gives me 7c. Bring down this plus sign. Left over here, you might think nothing's left, but it's always an understood 1 that's there. So we have a 1 that's left over. So this is our final answer when they ask us to factor 14c squared plus 2c. So this is leftovers. So when you're factoring, greatest common factor always goes on the outside. So that's your first step when you do any kind of factoring, and that's on the front of our foldable. So your greatest common factor goes on the outside. Everything else goes on the inside. The great thing about this is you can check your work by just multiplying it out, and it should give you 14c squared plus 2c. 2c times 7c gives me 14c squared. Check there. 2c times 1 gives me 2c, so we're in business. So 2c parentheses 7c plus 1 close parentheses is my final answer when they ask us to factor 14c squared plus 2c. Okay, let's do some more of this kind of factoring. Okay, so again, we're on number 5. I did a factor tree for 21b. I broke that down. I did a factor tree for 15a, and I broke that down. We're going to go back and circle anything that they say that they share. I only see that they share the number 3. They don't share any variables, and that's okay. So 3 is the greatest common factor. That's going to go on the outside. So your greatest common factor goes on the outside. Everything else goes on the inside. Left over here, I got a 7 and a b. You will multiply that. That gives me 7b. Bring down this subtraction sign. Left over here, I got 5 and an a. Multiply leftovers. So this is our final answer. Now, you don't have to write this step here that I'm doing. I'm just doing it for you, so as you copy and do your problems, you'll know what goes where. Your greatest common factor always goes on the outside. Anything left over goes inside of the parentheses. And the great thing about it, you can check your work by factoring. Let's do one more of this kind. So this one's a little longer. I'm on number 6. 10g squared h squared plus 9g h squared minus g squared h. So I got 3 terms for this one. And that's okay. It's a little longer, but I'm still going to go through. I did my factor trees. I broke down 10g squared h squared. So I did my factor tree here. I broke down 9g h squared. I did my factor tree here. And I broke down g squared h, and I did my factor tree here. We're going to go back and circle any numbers or variables that they share. I don't see that they have a number in common, but I do see that they have a variable in common. I see a G and an H. I see a G and an H, and I see a G and an H. So that is the greatest common factor. Each term, even though there's three of them, each term has a G and an H, a G and an H, a G and an H. Leftovers go on the inside. So if I just look at this first factor tree, if I take away the G and the H, what's left over? Well, there's a 2, a 5, a G, and an H. So we're going to multiply that. 2 times 5 times G times H is 10GH. Bring down the plus sign that the problem gave us. Do the same thing with the middle term. So if I look just at this one factor tree, I took away the G and the H. What's left over? A 3, and an H. So it's pretty much whatever you have in circle, but make sure it's a prime number. 3 times 3 times H. I multiply that. That gives me 9H. Then I got a subtraction sign here that I'm going to bring down. I took away 1G and 1H, so the only thing left over is G. So this is our final answer. So when you are factoring, your very first step is to find the greatest common factor like we did in these problems up here, 1 through 3. So that's your very first step when you're factoring. If you have multiple terms, binomials, trinomials, check for your greatest common factor. That always goes on the outside, and then leftovers go on the inside. Now, for boxes 7 and 8, I am going to do 2 examples in each box. So I'm going to do 2 examples in each box, just so as you're doing your foldable, you kind of know that I broke it up so that we have lots of examples. These are the kind of factoring problems that come up the most often. So I have a trinomial, a quadratic trinomial, something squared, and it's going to look like this. So we're going to be working backwards. So normally I would give you the 2 sets of parentheses. You would go through and you will multiply that using the box method or the distributive property. Now we're working backwards. So we're trying to figure out, okay, what was in the parentheses to give me this up here? So the first 2, let me put some little blanks here. Okay. So this and this is what are you multiplying to give you the first term? So something times something has to give me x squared. So that's the relatively simple part, x and x, because x times x gives you x squared. Now your numbers go in here, and you're asking yourself, okay, we need to think of 2 numbers that multiply to give me the last number, add to give me the number in the middle. Multiply to get the last number, add to get the number in the middle. One more time, because that's very important. It's got to multiply to give you the last number, add to give you this number in the middle. Now, besides just knowing your multiplication facts, some things that are going to help you out. I know that this sign is a positive. So what can multiply to give you a positive? Either 2 positives or 2 negatives. What's going to add to give us a positive? It must be 2 positives. So for this particular problem, I'm going to have 2 positives. So this particular problem, what are the 2 numbers that multiply to give me 42? Add to give me 17? That is 3 and 14. So this is our answer. It has to multiply to give you the last number, add to give you the number in the middle. And the rest of these are just like that. I just gave us lots and lots and lots of examples to look at. I'm going to go ahead and fill in my variables for each of these because I know something times something gives me n squared. That's n times n. Something times something gives me y squared. That's y times y. Something times something gives me a squared. That's a. Now, you need to think of 2 numbers that multiply to give you the last number, add to give you the number in the middle. So multiplies to give you negative 35, adds to give you negative 2. Multiplies to give you positive 72, adds to give you negative 17. Multiplies to give you negative 48, adds to give you positive 8. So just as a checkpoint, might be a good idea to pause it and see if you can figure that out. So it's got to multiply to give you the last number and add to give you the number in the middle. So hopefully you did try to pause before you watched and got your answers here. But these are your answers for these problems. It's got to multiply to give you the last number. So negative 35 adds to give you negative 2. Negative 7 times 35 is negative 35. I add these two numbers together, I get negative 2. Multiply to get the last number, add to get the number in the middle. And I want to look at another one. So I do got some problems on the back. Okay. Number 9. 2h squared plus 30h plus 88. Your very first step when you do any kind of factoring is to check for a greatest common factor. Now, I didn't exactly say that out loud for these problems, but I do know that they don't have a greatest common factor beside the number 1. So they don't have the same number of variable. They don't share the same number of variable. None of these had anything in common, which is why I technically skipped that step. But for problem number 9, they do share something in common. 2h squared, 30h, and 88 share the number 2. 2 goes into each of these. So 2 needs to go on the outside, and then everything else is going to go on the inside. 2 times what gives me 2h squared? That's h squared. 2 times what gives me 30h? 2 times 15. 2 times what gives me 88? That's 44. Now I can factor this like we just did in box 7 and box 8. Okay. Something times something needs to multiply to give me h squared. So I can break that down. And we need to think of two numbers that multiply to give me 44, add to give us 15. Multiplies to get 44, adds to get 15. So those numbers are 11 and 4. In the next video, factoring video, I'm going to show you how to factor if they don't have the greatest common factor. So it's going to be something called the 4-step method. So I'll show you how to do that in the next video.